Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
And by now it's January, and we've got we've done all of our December shows, and we're recording this in December 11th. So happy New Year, everybody.
And happy New Year to you too, buddy.
Yep.
All is well.
And what's new in the wild frontier that is your beach house?
I'm wondering about making a YouTube channel just about the logs coming and going from my beach house. Like, just add some silly horn noises and that kind of thing. Because when there's a very high tide and a bit of a gale blowing, you literally can have I had a log, a good size log, like you could ride this log, come into the boathouse, go all the way to the back, come back down the other side, and then wash out. Never touch the walls. It was just crazy. But it's like 1,000 pounds with a log bombing through there.
I have a picture in my mind of logs coming into your beach house being ridden by otters in sunglasses that are just sort of sitting, sunbathing on the back of the logs.
We did have 2 otters drop by in the morning the other day, but it wasn't a high tide. They don't. I think when it's stormy, they go, to the bar.
Well, that's what you ought to do. You ought to have an otter bar in the boathouse.
Well, there are pictures of the otters on the boat rails and eating shellfish. It's very cute.
That is cute. Who can say that they have otters? That's really just cool. All right. Well, let's roll the music for Better Know Framework.
Awesome.
All
right, dude. What do you got?
Well, I found this on a list of top 10 GitHub projects that every .NET developer should check out. And it's an open source platform really called Serenity.
Oh, yeah.
And it's an ASP.NET MVC TypeScript app platform designed to simplify and shorten development of data-centric business apps, so line of business apps, service-based architecture. The whole goal is to make development easier, reducing maintenance costs by avoiding boilerplate code and reducing the time spent on repetitive tasks and applying best software practices. So it's sort of like something that, the template in templates in Visual Studio are great, right, but this takes it to another level. And they have, the free MIT version, which you can get at GitHub.
Nice.
And they also have commercial support and a commercial option. I'm not sure what that is, but suffice to say that the MIT license provides the ability for you to use it completely in commercial applications. So
yeah, you got to think, if you're building forms over data, why wouldn't you work from a template?
Right.
Just, these guys have got to look to it. They got support for it if you want to spend some money as well. Obviously, there's a community around it. This is good looking, man.
It is good looking. Yeah. And, especially if you're not a fan of CSS and writing it by hand.
Sure. and who is really?
Who is, right? Everything's open. The programming model is declarative. Everything's responsive. It's just pretty good. And some people that you and I know really like it.
Nice.
Yep.
All right. That's cool. Nice find.
There you go.
Love it.
Who's talking to us, Richard?
Grabbed a comment off of show 1447, the one we did with Vishwas back in June of 2017 when we were talking about building cloud redundancy. So I think we're going to talk a little cloud today. So I thought
we're going to be in the clouds.
Into the cloud thing. And this is a comment from Matthew Fortunka, who said, this was a great show before going deep on this whole software thing. I trained as a chemical engineer. Which is not that unusual. Engineers end up at software because it's a way of thinking, and I think it's a good way of thinking too.
Yeah.
And what struck me was the parallels between the two professions, because I think software is an engineering discipline too.
Mm-hmm.
When designing chemical systems, we were taught to look at the seams between equipment, reactors, heat exchangers, pumps, and ask the following questions. How do these elements interact if we get more flow or less flow or no flow or reverse flow?
Right.
You're thinking about chemicals moving through a system, right? Just to think about what would happen there. It is the process of asking these same questions that creates robust systems. And while the questions may be different, like null data, bad data, excess data, or bad actor data,
right,
the same idea applies for distributed systems regardless of the infrastructure. I thought that was a great insight because I think it's absolutely true, especially when we think in the cloud, when we have all these different platforms and plugin models, where you really, you can probably trust that Cosmos DB isn't going to lose your data. Your question is the seams between, your Logic app tier and your Cosmos DB, and are you doing the right things in there, and how are you going to manage all these varying flows?
Right.
It's very insightful. And Matthew, thank you so much for your comment. A copy of Music to Code By is on its way to you. And if you'd like a copy of Music to Code By, write a comment on the website at .netrocks.com or on Facebook. We publish every show there. And if you write a comment on Facebook and we read it on the show, we'll send you a copy of Music to Code By.
And definitely follow us on Twitter. He's at Rich Campbell. I'm at Carl Franklin. Send us a tweet. Serenity now!
Wow, a little George Costanza. All right, I can do that.
I was George's father, actually. Jerry Stiller.
Oh, that's right. Yeah, George Costanza's father.
Serenity now!
Is he ever named? I don't know if he's ever named.
I think he was. I just can't remember. That was the 90s, man.
It's a long time ago.
Way back in the 90s. Anyway, let's bring on Vishwas Lele. He's been on our show many, many times. He may have been one of the first people to talk about Azure on .NET Rocks.
Pretty much.
Michael Stiefel, yeah. He's an Azure MVP and a regional director and CTO at AIS. Welcome back, Vishwas.
Thank you, Carl and Richard. Glad to be back.
Very, very good to have you back again. We have the topic of becoming cloud native. Now, what does that mean? Just cloud first?
Well, cloud native is something that has come along, I would say, in the last 2 years. And I should say that, like your listeners, I'm also trying to understand cloud native. I've been a cloud guy, as you said, for a number of years.
Yeah.
And then I've been watching with a lot of interest and using some of the projects that form what is known as the Cloud Native Computing Foundation, which is a foundation under the Linux Foundation. And the idea is that it is think of as a platform for incubating a number of projects, and Kubernetes, of course, is being the most prominent one and probably the first one, but there are a whole host of projects. And the idea is that if you use the general principles of cloud native computing and you use these projects, then you can build a modern application which can run well, not only in a public cloud, it can run in any of the cloud providers, whether it is AWS, Azure, or Google, or it could also run with using the same principles, run well in a on-premises environment. So it's really about rethinking your applications so that you are taking advantage of sort of the modern principles of cloud native development, as they call it.
Mm-hmm.
So more cloud as architecture rather than cloud as product.
That's right. Although there is a product component of that. So that's very interesting. So, of course, Kubernetes has sort of taken over the world, it seems like. And, there was, when we talked last time, there was a war between various orchestrators, container orchestrators, I should say. And everybody seemed to have settled that Kubernetes seems to have won this debate. And Kubernetes, of course, came out from Google's long years of learning how to run these large number of containers at scale. And, I was reading some article a few months back that they may even be spawning something like 1 billion containers a week. There was an article maybe 2 or 3 years old.
Jeez,
so they had to
crazy.
So they had to learn a lot of things about how to manage that at scale. And they developed certain tools and systems to manage that and a framework internally to develop that. And then they decided to take parts of that framework and lessons learned and created Kubernetes. And rather than making just a Google open source project, they went ahead and created this Cloud Native Computing Foundation, and which is part of Linux Foundation, gave that project. So that's the first project to graduate out of CNCF. There are other projects that have graduated, 2 other projects. But what is very interesting, Richard and Carl, is that CNCF is not a standards body, and we've seen how that has ended for us in the past. So they're not saying we are going to write these standards about how you should be writing the app service and how you should be doing the networking and things like that, they invite projects which have already gotten some traction, and Kubernetes was one of them. And the recent addition is Envoy, for example. These projects have gotten already traction with the community and the industry. And then you can become part of the CNCF. And, as long as you agree to follow the code of conduct, CNCF is not micromanaging these projects.
Sure. Well, so we really just need a sort of a buzzword to shorthand. We're using containers, we're using microservices, we're using orchestration, and we're not necessarily managing individual services. We're not using VMs, right?
That's right. So the idea here is that the principal part, what Richard was saying, the principal part is that you build your applications not as monolithic units. You build them as smaller units, or microservices, if you like to call them. And the idea is that if you have these small components, you can scale them better. You can incrementally change them without having to do one big rewrite. There are a number of benefits. They use an interesting term called the blast radius. So if something happens to one microservice, your entire application is not taken down. So I think everybody, whether you want to use the term microservices or not, everybody would agree that that's a good idea. To build your application.
That term blast radius, Richard Campbell uses to express how much you liked the meal.
That's a new usage for me. But
no, but you're smiling because you've seen meals like that. It may not have been you, but you definitely know when a 2-year-old has liked their meal, because it's a heck of a blast radius.
Sorry, I didn't mean to derail a serious conversation here.
Serious conversation, yes exactly. So what I was saying was that there are common principles of microservices, and then once we have microservices, microservices, like anything, is not free. So you have just suddenly blown up the number of moving parts in your application, and now you need better instrumentation, better observability for your containers and scalability and things like that.
Right.
So then you need other projects. So if you don't take those principles, which I think we can all agree on are good principles for building your modern applications, now you pair them up to popular projects that have been trying to accomplish this. So Kubernetes, for example, a great way to, if you have lots and lots of containers, and then how do you distribute them across machines?
Yeah.
So, one of the common problem we have talked about in the past is, hey, you're paying for the entire VM, but you're only using 10 or 11% of the capacity because that's what your CPU utilization is.
Right.
So one of the things orchestrators can do for you is optimally pack these containers so that you're making the most of these machines. So Kubernetes becomes a project of CNCF, and it meets certain criteria. So it's the first project to get graduated from CNCF. The other two being Envoy and something called the Prometheus.
Should we talk a little bit about these? Because they're obviously different, but it's interesting to think about in the context of cloud native for these projects.
Yeah, so we should talk. And those are the 3 graduated ones, but there are a number of other ones which are in the incubating stage and other stages. And there's a whole movement of projects, and which is incredible for me to watch as how much development there is going on. So let's just talk about, Richard, what you said. Kubernetes, we have already talked about an orchestrator that can manage your containers and give you resilience and things like that. Let's talk about Envoy as the other project that got graduated from this. And Envoy is something that came out of Lyft, the car hailing service. Lyft needed some proxy, a high-speed proxy to manage a lot of their internal applications and things like that. And your listeners there's a very good talk by the creators of Envoy that you can listen to. But Envoy became this highly scalable proxy, which is then used in conjunction with Kubernetes. So in order to explain that, let me step back.
Okay.
So for Kubernetes, for example, and Envoy is more than Kubernetes, but let me explain. Envoy in the context of Kubernetes, if that helps. So, there's another pattern which has sort of taken the world by storm called the sidecar pattern. And, when I describe to you, your listeners will say, okay, what's new about this? But hang on. So sidecar pattern is, so we've talked about containers. Let's talk about a new term called pod, which can be a collection of containers. And that's the smallest unit of deployment in Kubernetes. So let's say I have a web application. I can drop that into a pod. I can also have another container, which is commonly termed as a sidecar, which can take advantage of the unused cycles by my primary container and do some things like, I might have a web server, which is going and writing stuff to some logs. And then I might have a sidecar, which may take these logs and push it out to some cloud storage. So, that's the sidecar pattern. That pattern turns out has taken a lot of prominence because using that sidecar, people have been able to do certain interesting things. Now, let's park this over here, come back and talk about Envoy. So what people have been able to do is take Envoy, inject it as a sidecar. So I might have an application running in container inside a pod. Now I can inject an Envoy sidecar. And by virtue of having the sidecar, I can now monitor the traffic. Since it's a proxy, all the traffic is flowing through Envoy. And it is high speed, so it is not impacting your performance. And now by virtue of having that proxy, I can essentially improve the observability of my communication between these containers. I can apply traffic management rules. I can say only send 2% of my traffic here. I can do all kinds of things there. So Envoy has taken this important role of, you probably heard of a term called service mesh, which is about managing these microservices containers at scale. And there is one other way to describe, which I found quite useful, of describing Envoy is, up until now, when we write applications, so leave containers aside for a second. Let's say you're using traditional virtual machines and a virtual network to build your application. When you were deploying your application, so you created this topology of network and then you brought someone else to deploy your application there, then the application developer really needed to understand what your network topology was, right? They needed to understand how the traffic is flowing. They needed to understand, hey, how will I hit the internet? And, if I have hybrid connectivity, where will my traffic flow from? What are my user-defined routes? How are my screening traffic between different network segments? So I really need to understand these, otherwise my application will not work, and I spend time debugging that. And which has been
just
a challenge.
The nature of debugging these microservices in and of itself, especially in production, is just practically impossible without something like this.
Right? So what the other way, you're absolutely right. The other way the Envoy has been described is, think of this network for the applications. So you are bringing the network essentially. You're hiding the complexity of the underlying topology and user-defined routes and what have you, and bringing it to the needs of the application. So that's the other way to describe it, which I thought was pretty intuitive, because now I don't have to worry about sort of the underlying details. So the other thing to talk about here is, if every time a container came up, and your listeners will know, every container gets its own IP address.
Yeah.
And every pod gets its own IP address. So if we were to get a new IP address every time, and we had to go back to the Azure portal and get ourselves a new IP address and muck around with those details, that would never work. What we would need is something dynamic which does that for us. So those are the kinds of projects. So I talked about Envoy, Richard. We talked about Kubernetes, of course.
Hey, before we leave Envoy aside and move on, I just want to let everybody know that Envoy, the performance comes because this is it's written in C++, right? And it's out of process. So it's got a little stub, and then it has this out of process architecture. It's a very small memory footprint.
Very important point.
Yeah.
Carl, sorry, I didn't mean to interrupt you, but two very important points. You did a better job of describing than I did. Written in C++, and just to give you an idea of numbers, they talk about, I've obviously not tested this myself, but the creators of Envoy talk about something like 1 million messages a second, being able to handle that kind of volume.
The technical term for that is stinky fast.
That's a good enough standard for me in terms of how well it scales.
Yeah. Can you just hold that thought for 1 minute while we take a moment for this very important message? This episode of .NET Rocks is brought to you by Datadog. Datadog integrates seamlessly with container technologies like Docker and Kubernetes, so you can monitor your entire container cluster in real time. See across all your servers, containers, apps, and services in one place with powerful visualizations, sophisticated alerting, and distributed tracing. Start monitoring your microservices today with a free trial. As a bonus, Datadog will send you a free t-shirt. Visit dd.netrocks.com to get started. Okay, we were talking about Envoy, the small memory footprint, but there's something else that you wanted to mention there.
I wanted to reiterate on what you just said, Carl, which was, it is out of process. And that's very important because let's say I have a microservice already deployed, and then I deploy another microservices as part of my orchestrator, and I'm making a call into the microservice. Now, we know a good practice in building cloud application is to inject proper retry logic. We know that transient faults can occur in the cloud. A good principle is to have some sort of a circuit breaker pattern.
Yay!
So you have to have these kinds of things. We talked about this in the last time, the resilience talk.
Sure.
So people listening to this talk will say, hey, fine, I have libraries like Poly, which I can inject as part of my client, and I get that capability. Of course you can, but then you have to inject, or you have to include that as part of your application. Being out of process means you can have those circuit breaker, traffic control, retry logic in and out of the process manner, so you can go get new libraries and change them and things like that.
Right.
So that's a very important principle. Then your core application is not burdened by having these capabilities.
I also should mention that in an up-and-coming version of Poly, we're going to support serverless architectures, because the problem with serverless and functions and lambdas is there's no state.
Right.
And how are you going to retry if there's no state? So how are you going to keep any kind of metrics and figure out what to do if you're retrying a number of times? So that distributed architecture is really important.
One of the questions I had here, Vishwas, is why did Lyft bother to write yet another proxy? Because we've had HA proxy and Nginx for ages. Like, why add another one?
That's right. In fact, if you look at the Envoy page, envoyproxy.io, I believe, and you go through the background of why they created it, they do say that they learned from the existing proxies, the ones you mentioned, the HA proxy. They said they learned from that. They've incorporated many of the things that they learned. They had some specific scaling requirements, for example. The other important difference is that by default, they support HTTP2. Others support HTTP2, but by default support others. So there are things that they needed, which is an extension of what was already available.
I think you're also walking carefully around that both HA proxy and Nginx ended up making commercial versions. And so their best features are sort of only available in the commercial version. The open source didn't get the best bits. And so, at some point, if you were using Nginx and you pushed it to a certain level, you had to turn around and buy the closed source Nginx Plus.
Yeah.
It just doesn't make sense. And Lyft doesn't make money off of writing proxies. Lyft makes money off of providing rides. So they just decided to make the best proxy they could and simply release it, which kind of blows up the other guy's business models to some degree. But it's a proxy.
Yeah. And, you imagine the excitement around a proxy, which it is.
Woo. Make it fast, give the core feature set, maintain it, go.
And then work with communities to incorporate the proxy into different environments. It doesn't matter. You could be running an application which is running on completely IaaS or VMs, you can inject Envoy there as you can within a Kubernetes environment. So I think that's the other part that is really flexible and powerful for people to use.
I didn't think we could talk about proxies quite this long. I'm kind of impressed with that. Because we still haven't talked about Prometheus.
We haven't talked about Prometheus, which is the third project to be graduated. I can't remember the order. Maybe it would have been the second to graduate, and Envoy is the third one. But those are the three that are graduated from CNCF.
Mm-hmm.
So Prometheus is, think of it as a highly dimensional store, time series store for capturing this information, all of the information that is emitted by your systems. So that's essentially Prometheus. Has a powerful query engine, great visualization, stores time series data.
Yeah,
and it has alerting built in, and integration with other platforms. So integration with the Docker HA proxy, StatsD, JMX. So it provides you a lot of these capabilities. So which, Richard, begs a question that which really brought us to this conversation, if I may go back when you and I were talking over email last week, is so you have these interesting projects. You have Kubernetes, you have Envoy, you have Prometheus. How does it relate to the services in Azure, and what is the link between the two? How should Azure developers who have been using the PaaS services for last many years think of these services, and how should they architect them in a cloud native world? Does that sound like a good question that we want to discuss?
Absolutely, because I think this is sort of gets to the essence of this whole idea of, if I'm cloud native, what am I doing different?
Right. So I think it will take a few months or maybe longer to play out and see how it goes. Microsoft, of course, last November, 2017 November, became a platinum member of CNCF, like many other companies. So they've been actively supporting them. They, of course, have a compliant Kubernetes implementation, which is the Azure Kubernetes service. So it's a fully compliant Kubernetes implementation. So if you're an Azure developer, you can write your microservices using AKS, and you are now writing in a manner that is compliant with CNCF. So you will be able to take that application, move it to another public cloud provider, perhaps, or even an on-premises provider that is compliant with the CNCF Kubernetes standard. So that is clearly Microsoft is going in that direction. And, of course, they've been doing other things here as well, right? There's something called, very recently, I think it was the Ignite timeframe, or maybe earlier than that. So CNCF, as I mentioned earlier, they're not trying to be the standards body there, right? They're projects first, as they like to call them. So, hey, Envoy looks interesting, has a lot of momentum behind it. Can we bring Envoy into the umbrella of projects that we incubate and we, promote and things like that? And the idea is that, by bringing projects from different types and requirements and functionality, you are providing a full stack cloud native development along with tooling. Of course, without becoming something like an open stack, which is, a complete stack by itself, which is, one, the way to describe it would be one monolithic stack. Of course, it's open source.
Open source, but monolithic.
But here, your stack is essentially defined by a collection of these projects.
Yeah.
Right.
So you could write Kubernetes and you could be fine, and then things like the new specification called cloud events, right, which is very pertinent to the serverless piece we were talking about. That wouldn't it be great if we had a common schema to define a cloud event? So it turns out that there is, even though CNCF does not set standards, they are big about projects and they're big about interop. So we'll talk about a couple of examples of interop. One would be CNI, container networking interface, container storage interface. So they are about interop. Hey, projects, you can all come here and you can, prosper, but can you, interface with each other using these container network interface, container storage interface, and things like that. Right. So similarly, they defined something called the cloud events. So Microsoft said, great, we will support cloud events. In fact, when Corey Sanders did a blog post, he said Azure was the first cloud provider to support cloud events. So if you go to a service like Event Grid in Azure, you have an option of being sent a message which has a format that's compliant with cloud event.
Booyah.
Has he been on this show?
Yes. And the reason for the booyah is we were in Sweden and we started drinking wine at the beginning of the show. By the end of the show,
everything was booyah. Booyah.
It's an hour-long show. We were a little booyah.
All right. Cloud events. Let's get back to there.
So we were just talking about cloud events as again, a common standard. Now, a cloud provider like Azure comes along and says, hey, we will support this natively. You can go use our Azure Event Grid service, and we will emit an event which complies to the format of cloud events. So where I was going with this answer was, of course, Microsoft is embracing cloud native. So you can use services like AKS and Event Grid with has cloud events. And, similarly for networking, the Azure networking team implemented something called the Azure CNI. So, they bridge the gap between what a container or a pod needs in terms of networking and what the underlying Azure networking provides. So they're doing a lot of work in that area. The question I have is, what about services like App Service, right? Which are great services, very popular, being used by lots of people. How does that play into the cloud native world? Because, clearly app services can do containers. You can bring a container and right. Say, hey, container, run this. In fact, there has been a containerization across the board of Azure services, whether you are Azure Batch, whether you are app service, you can bring a container. So while you can do containers and you are embracing that aspect of cloud native, but the orchestration part is still app service, and that's not Kubernetes. So those are the kinds of things that people need to pick and choose. And if you are building an app service, unless you're running an Azure stack, you can't run that app service application in an on-premises environment or another cloud provider. So right. Those are the other considerations that start coming into play there. And this is why I said remains to be seen how the cloud native story evolves. Yeah.
I'm also looking at like the cloud native trail map and so forth. And like, they're pretty container centric. I love this idea of coming together and working around standards, but where is serverless in this tapestry? Because I'd love to have a serverless model that was cross multiple platforms.
So absolutely, Richard. In fact, they have a serverless working group as part of CNCF, which brings together the intersection of serverless with containers. So they are absolutely going in that direction of being able to do serverless, which is in a cloud native manner. So you can essentially take your code and run it in any environment. Now, if you look at Azure Functions, they make their entire runtime available as a container itself. So, by definition, you can run that container runtime in an on-premises world if you wanted to. So that's certainly part of that. I think there's a lot of work to sort of look at the intersection between containers and serverless and try to bring that into the fold of the cloud native.
Well, and just to clarify, it's like, serverless doesn't mean no server. It means you don't own the server. And serverless doesn't mean no container. It means you don't own the container. So the idea that we'd have a set of commonly configured containers that represent typical workloads to the point where it's like, just run this for me. Don't worry me about orchestration or instancing or any of the things that we normally have to think about with containers. That it just goes away. I just run my code. That's all serverless actually is.
That's right. In fact, Microsoft have done some really interesting work. As you know, there is a service in Azure called the Azure Container Instances, which is really about hey, I have a container image and I need to run it, and I'll just give you an image. I don't want to worry about orchestration. I'll just give you an image and quickly start up my container, and I'll pay for just the cost of running that container.
Yeah.
Right.
So that's the Azure Container Instances service. What I really liked was, so you can go to Azure Kubernetes service, and of course, what that service does is it gives you a control plane, which is the entire Kubernetes control plane, and then you get to bring your VMs where these pods get deployed, right? But you are now paying for each node in that cluster is nothing but a VM, so you're paying by the VM, right? Now, what they've done, so it's a very, Richard, to your point, it's a very container-centric architecture. Now, here is where we start to mix these terms. So what if you want to suddenly handle a workload where you need to spike up? You let's say you have a bunch of microservices, and now you get some spiky load put on this AKS cluster. You can certainly start adding more VMs and adding more nodes to the cluster, but that will be slow. So they've created essentially a connector where you can say, hey, if I need to burst out to handle the spiky load, create me a virtual node, which essentially means is it will go over to container instances and then spawn up a bunch of containers in the container instances without you having to pay for that entire machine or even wait for that machine to be added to the cluster.
Right.
So people describe this commonly as serverless containers, right? So some really interesting things happening, and I would be remiss to say that so Kubernetes is AKS is a compliant Kubernetes implementation, but what does AKS bring to the fold? Well, what if you wanted enterprise role-based access control? What if you wanted to integrate with Azure AD? What if you wanted to give granular permissions to your users? So I'm a compliant Kubernetes implementation, but I will give you other capabilities which may be needed by your enterprise, like role-based access control or common event logging and so on and so forth. So a lot to digest sort of what's happening, but what I like about this space is, so we are taking sort of the good principles of building these cloud native applications. We are bringing these projects that have traction in the community, and then we are forcing cloud providers to adopt these projects. So if this bandwagon continues to gain momentum as it has been, then I think all of us as developers and our customers stand to benefit, because we can write these applications which are adhering to these principles, plus we get the momentum that is powering the development of these tools and projects.
It just keeps evolving. And this is what I love about the cloud space, is that, as it seems like iterations take less time for things to just work. Like by the time you've figured out that you need a tool, it probably already exists.
That's right. That's
things have, I think one of the angles you had there, Vishwas, is a little subtler to grab onto, is ultimately it's not in the public cloud provider's best interest to build universal tools that make you portable between the clouds. They want you locked in. And it's interesting, the Kubernetes started out as a Google product, and then Microsoft picked it up, and then Amazon picked it up. I'm curious as to the engine that it takes for us as a community to kind of force these cloud providers into, this is table stakes, you must have these things.
That's right. That is right. And that's what for me, the amazing part, that in the short period of time that this organization has existed, maybe 2 years, because of the support, they've been able to force the providers to embrace these projects and bring them as part of their offerings. And there are some other benefits to be talked about here, right? If you look at Kubernetes, for example, one of the benefits is that it optimally places these containers on the nodes, and something we call bin packing, right? Which is, so if you're paying for the VM, you are using that VM to the fullest. So now we are talking about significantly reducing the cost of running these applications, because you can run multiple of these applications using the same footprint. Now, you of course have to worry about every time you say that. It's not easy, I realize, because now you have to worry about the logical separation of these applications. Do you want Dev 1 and Dev 2 environments to be on the same cluster? You may or may not want it. Or do you want the production to be in its own physical cluster? You have to think about those things. But even so, it is forcing people to think about, I've seen too much wastage where people just spin up these VMs, have the lift and shift of these applications to the cloud. And yes, I am now in the cloud, but I am paying this much amount of money without fully utilizing the power of the resources that I'm paying 24/7. So once again, we are forcing the users to think about these things carefully and pay only what they absolutely must.
This totally feeds back to serverless, where serverless, you're only paying for your code to run. And the moment it isn't running, you stop paying. As opposed to containers, where you're still paying for the container services and all of those bits, as opposed to VMs, where you're owning the instances of the VMs and the maintenance, as well as the ongoing minute-by-minute cost.
That's right. So, as you said, with serverless, you're paying for the times that code has been executed, assuming you're using the dynamic plan. Of course, you have the dedicated plan in Azure as well, if you wanted to have a dedicated capacity. But what I described with the connector model, Richard, where you are paying for the nodes. Let's say you have a 5-node AKS cluster, but then you have a burst out need where you just spin up more pods in container instances and you pay for that time. As soon as those pods come down, you stop paying for those. So that's another model in between the serverless model and a fully dedicated VM model. So you have to think carefully what your application needs, which model will work best for you. Of course, all those considerations come into play. But the good news is that we have these options. And as developers, we need to understand how to take advantage of these constructs so that we can build the most cost-effective application for our customers and for the organizations that we work for.
I got to think that some folks are looking at this and going, all of this infrastructure is about brownfield migration. That given a true greenfield cloud native opportunity, it'd just be serverless. Is that reasonable, or do you still see that even when you get to start from scratch, there are places where you want to own and control the containers?
So that's a great question. I'm not sure if I can give you a definitive answer because I have not.
You can go with the standard, my friend. It depends.
I can go to it depends. I've tried to ask that question of myself a few times, and I don't think I've given a convincing answer to myself even. So let me try to unpack the question that all the things that you're talking about are, hey, these are all existing applications and you're converting them over to the cloud, and this is probably the best thing you can do. If you were to rewrite these applications, won't you just rewrite them as a serverless application? Mm-hmm. And somebody said recently, I forget which forum, that isn't container sort of the last form of dinosaur computing before we get rid of this dinosaurs and everything becomes serverless? Somebody said something like that. And that was an interesting, thought-provoking comment. Now, what you have to think about is, can you have applications that require non-trivial logic, which will require non-trivial state management, have a long-running processes? Can you run those in a serverless environment? Now, I'm sure people listening to the show will say, hey, you have durable functions now, which give you this capability of a long-running function with some state management. So, functions are not staying still, right? They're evolving as well. So you're getting more and more capability there.
Yeah. Mm-hmm.
But I also think about, all the dependencies is the biggest problem. In my mind, when you are building these applications, your dependency management is one of the hardest challenge for you to manage. And from a container standpoint, being able to take out all your dependencies and creating a hermetically sealed container which is immutable, that's a definite advantage if I'm writing a non-trivial application which has non-trivial dependencies. And in serverless, I still have to deal with the dependencies. When my execution context gets enabled, I have to first worry about a cold start problem, and now there are some solutions to that. But people have dealt with on the serverless side the cold start problem, because hey, you were not even in existence when this call came in, and you have to go through that cold start cost that you have to bear. But even if you solve that, the execution context in which that function is running, are all the dependencies there? Are the right versions of dependencies there? Mm-hmm. So you have to think about it, right? So that's why, I wish I would have built a non-trivial application just using serverless, and I don't think there is an alternative just doing that. I've not done that myself. All my functions have been very episodic in nature, where I was receiving an event, I wanted to do some processing, and then write here or send some message out, which are sort of the canonical use cases for functions.
Well, I've also seen peel-offs, right, where it's like, this is the piece of this app that's struggling with performance. Let's try it in a serverless architecture so we stop fighting adding more VMs or adding more container instances and so forth, and we can just take care of this piece. So it always does seem to be the exception.
That's right. Some of my enterprise customers, the other factor that has come in, and Microsoft certainly trying to solve this, is so when you're running in a dynamic plan with functions, many of these financial services customers, or customers in general who are in a very controlled sort of environment, they're very careful about what is their network segmentation. Is the function, that code that is running, that execution context, directly connected to the VNet, or am I being sort of running an environment which is shared by others? Mm-hmm. Right, and many of those capabilities are coming now. So VNet is, the Azure networking team has made VNet available, for example, for Azure container instances. So you can spin up a container and say, hey, this container instance is the only entity that can talk to Cosmos DB, even though this container instance is not directly connected to VNet. So some of those network isolation functionality is being introduced, and I think that will make it easier for sort of more complex, larger enterprise kinds of applications to be built on that serverless platform. People may have already done that. I just haven't done that. And if your listeners are listening to this, I would love to see the comments of people who have built large-scale applications and things that they've run into.
Vishwas, this is all great stuff. And can you give us some resources for further reading, or maybe places that you're speaking, or webinars, or anything like that?
So I would say a couple of things. One is the CNCF itself has a place where there are a number of tutorials to get started, workshops, hands-on labs. Even on the Microsoft side, Brandon Burns, who leads the AKS development, has many talks at Ignite. I would encourage you to go watch that. The videos from October this year, 2018, a number of talks related to Kubernetes and cloud native. And very in good. General, look at the landscape of cloud native projects on cncf.io.
Awesome. Thanks a lot, Vishwas. It's been great.
Thank you.
All right. We'll talk to you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Pwop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time. Got transmitter banned by the FCC. Yes, I'm a